Welcome to solverfy.
Okay, so we've got 4 molecules. Chlorine here, chlorine here, chlorine here, chlorine here. Oh, sorry, that one's bromine. Number 3. And number 4. And the question is, which of the following can exist as a meso isomer? Okay, so remember what's necessary for a meso isomer. You need 2 or more stereocenters. Okay, that's rule number 1. Okay, they need to be identically substituted. Okay, that means if you have 2 or more stereocenters, there needs to be matching pairs for those substituted stereocenters, unless you get a case where you say have 3 stereocenters, in which case you can have, say, a central stereocenter. But nevertheless, you've got to have, if you have a chlorine on the left-hand side of the molecule, you've got to have a chlorine on the right-hand side of the molecule. Everyone's got to have a matching pair and be identically substituted, unless it is a central stereocenter in a molecule with an odd number of substituents. But that's not the case here, right? Each of these has 2 substituents, right? Chlorine, bromine, or we could think of it as methyls. Okay, so right off the bat, that tells us, well, maybe 2 is a problem, right? This is clearly not identically substituted, right? If we need to have it be superimposable with its mirror image, which is the other sort of defining feature of meso compounds, if we mirror imaged bromine and chlorine, regardless of whether the stereocenter directionality matched, you can't match up bromine with chlorine and chlorine with bromine, right? So it clearly cannot be 2. Okay, so identically substituted throws out 2, and the same is true for 3, right? We've got a single. For 1, we could think of it as we only have a single stereocenter, because this is not a stereocenter. Having 2 methyl groups, it can't possibly be a stereocenter. So we can throw it out for that reason. Or if we think of this as being substituted with a methyl group, then it's not identically substituted to the bromine. So 3 is out. Next up, we have 4, which we can also throw out. And the reason for that is that we need 2 or more stereocenters. And this is not a stereocenter, and neither is that. Because remember, you need 4 unique substituents to be a stereocenter. Each of these clearly has 2 methyl groups for its substituents, which is not possible for them to be stereocenters then. Okay, finally, we have molecule 1, which we can look at. Right. Well, we've got 2 or more stereocenters. It is identically substituted. Okay, so it's possible that this can exist as a meso isomer. And then from here, we might want to consider what rotations we could take around the bonds to make it more obviously or clearly meso. So I'll show you what would happen geometrically if we were to rotate around that bond. I would be rotating it such that the chlorine is now pointing up, and the chlorine here is pointing up to the left, which now is more clearly contains a mirror plane of symmetry, right? If we cut down or reflect it across that line, the left and the right match up perfectly. This could be, if we made these both wedges or both dashes, a meso compound.